radius 0. Nobody's guaranteeing us all that much convergence. Well, as an example, let's consider this power series. The sum n goes from 0 to infinity of n factorial times x to the n. For sure, if x is equal to 0, then this power series converges. Yeah, so what happens when x is equal to 0? Then this series is the sum n goes from 0 to infinity of n factorial times 0 to the nth power. Now, what is this sum? Right? Does this series converge? Well, I prefer the convention that 0 to the 0 is 1. And I think pretty much everyone prefers the convention that 0 factorial is 1. So the first term, the n equals 0 term of this series, is equal to 1. What about the next term? What about the n equals 1 term? Well, that's 1 factorial times 0 to the first power. That's 0. What about the next term? What about n equals 2? That's 2 factorial times 0 squared. That's 0. What about n equals 3? That's a number times 0 to the third power. That's 0. What about n equals 4? That's a number times 0 to the fourth power. That's 0. All the other terms in this series are 0. So this series has the value 1. It converges at x equals 0. But are there any other values of x besides 0 for which this series converges? So I know this converges at x equals 0, but let's suppose that x is some non-zero number. Then does this series converge or diverge? Well, let's check it with the ratio test. So I'm going to look at the limit as n goes to infinity. What's the n plus first term here? It's n plus 1 factorial times x to the n plus 1 divided by just the nth term, which is n factorial times x to the n. I'm looking at the absolute value of that. What's this limit? Well, I can simplify this limit. Right? This is the limit of what's n plus 1 factorial over n factorial. Well, that I can simplify a bit. Right? That's just n plus 1. And then I've got x to the n plus 1 over x to the n. That's just x. So for some fixed value of x, which isn't 0, what is this limit? Well, if x is anything but 0, this limit is enormous number times non-zero number. This is very, very positive, right? This limit is infinite, and that is bigger than 1. And what that means is that by the ratio test, this series diverges. For any fixed value of x not 0, this series diverges. So it doesn't converge anywhere else. It only converges when x equals 0. So in other words, since this series only converges at the point x equals 0 and diverges whenever x is not 0, that means the radius of convergence is equal to 0. Let me leave you with a question. Try to think up other power series with radius of convergence equal to 0. Can you think of any other examples?